So whatever we have discussed now, that was about the array. Right. So when I talk about the array, so in array we have the sequential access things are there. So suppose this is a array allocation. So there are eight elements are there. So suppose one element is here. So the address of this will be one. Then this will be two. This will be three. This will be four. This will be five. This will be six. This will be seven. This will be eight. Okay, so now whenever I have to store these eight elements will be uh, stored in a sequential manner in this, right? So this sequence will basically um, be maintained for the execution, and whenever the array will be declared. So what will happen? It will first of all in the entire memory, it will search out for this eight continuous allocation, right? Give me a second. Okay. बंद कर लो बस. Okay. So whenever we are going to create an array, so there will be a continuous memory allocation like this. So suppose if this is going to be the integer array. If it is an integer array, and integer takes the 32 sorry, in one integer takes suppose 4 bytes. It is different for each language. So I'm just assuming that one integer takes 4 bytes. So for this overall it will take 32 bytes for the allocation, right? Now it needs all these 32 bytes to be consecutive at one place only. Now suppose this is your memory size. Let's suppose that this is your memory size. Okay, so here one, two, three, four, five, six, then one, two, three, four, five, six, seven, eight, nine. Okay, this I am taking one more. Okay, now has stored some value in this space. Okay, so let's suppose somebody has stored from here to this. Okay, so let me just highlight this. So it has stored this, and 6 and 8, somebody has taken this place. Okay, now so one another array has been assigned. That array is taking this place, this and this place. This is the second array has taken. Let me take this different color. So this is the second array. Now a third person has come. Third person is taking taking the space like this. Okay, so here, and let me take a different color over here. Okay, so now these three arrays are assigned, and let me assign one more array with this with here this. Let me take the different color for here. So let's see, it is green. Okay, and this also green. Now you can see here we have suppose how many elements. This is 6 and 10. So overall 60 bytes we have available. Okay, now this is the total memory. Okay, now used memory is what is the amount of used memory. This is 6 to 8, 8 and 10, 8 and 18, 18 and 10 again, 18 and 10, 28 and 28 and 6, 28 and 6 is 34 and 5, 39. So total we have 39 are occupied. Now free memory is of 21 byte, right?
Yeah.
Now somebody comes and say, I want to create a new array which requires 16 bytes for the allocation, right? Now in general way you can say that we have the availability of 21 bytes and you need the 16 bytes. I can give you, but what if this is the array? So now array needs the 16 bytes continuously. So now out of these three blank blocks, right? So you have the availability of 6 and 4, 10, 12, and 12 over here, 6 over here, and 3 over here. So out of these blank box, you have the availability of 21 bytes, but
Yeah,
still you will not be able to allocate these 16 bytes for this array.
yeah,
Understood? Why? Because there is no continuous memory allocation available.
got it.
So because of that, you have the availability, but you will not be able to accommodate the data in this manner. So for this reason, there has been the concept of linked list introduced. So what linked list does is linked list. So what linked list is doing is, it is basically what it does is, it stores some memory allocation. Suppose first element is 45, it is storing. Along with this 45, it will contain one additional space, and what this additional space will contain will be the address of next element. It will contain the address of next element, right? So
Yeah,
now it has the address of next element. Now our suppose next element is at suppose this is L13, right? So it will contain L13. Right now at L13, here is the second element. So suppose this is 67. And along with this, it will contain the address of next element. So like this, a chain will be created where every node will contain the address of next element till it reaches the last element. Okay. So in a way, you can visualize it like this. So we have a node like this, and here this is the element. So suppose this is, suppose 20 is there, this will contain address of next element, and this will be like this. Okay, so here now this is suppose 24, and this is the address, so it will refer to third place, right? Then
yeah,
here this is the suppose 35 is there, and this is next. Now whenever there will be the last element, the last element will contain null. Okay, so this is the starting element, and wherever the address part is null, that is the last element. This is
okay.
last element, and this is first element. Okay. So
Yeah,
in array, when we used to travel in array, we used to traverse in array. We need to first find out what is the length of the array. Okay. So with the length of array, we can do the looping process with the array. But in case of linked list, you need to find out where the null element is there, and till that place we can traverse our array. Okay. Is this
okay.
clear? So
Yeah,
for this, you need to make a separate space for each- for um, the structure of this. Then you will be able to structure this element. So for this, when you will do, so let's see that how can we create the code for this part, and then how this will be used in our code. Okay. So let me share the coding screen now. Okay. So with the coding, let's start with the linked list. Okay. So in linked list, so first of all, we have to make a structure other than the normal, and this class node will define a structured definition, and we are taking inet. Have you studied the object oriented concept?
Yeah,
So you must be aware with this class and
yeah, yeah,
inside that
yeah,
those variables, right?
yeah.
Yes, I was worried about in that whether you have studied the object oriented or not, because now advanced programming we will be making lot of class and will be using lot of inheritance properties and all. So those
So every time we use linked list, we would have to make our own class, or would there be something in Python?
sorry.
So if we want to use linked list, then we would first define a node class, or is that in Python available?
Yes, every time whenever you are going to use the linked list or means such a dynamic memory allocation, so linked list is one of them, right?
Yeah,
Linked list is one of them. Are you able to see my screen? I guess there is some network issues there.
I can see it.
Okay. Mm, it is stopped. There is some network issue. Let me share my screen again. Okay, is it visible now?
Yeah,
Okay. So here now we have two things. One is the self. So do you know what is this self?
hey, one second. So self, I don't know, but I know that we need to use it when we are defining arguments.
So the self class is basically the this is a pointer towards itself, right? So if you want to use the variable of the own class itself, for that we use the self. Okay.
Yeah,
Okay, so now here I have defined the class. In this class, there are two things. One is self dot data, which will contain the element, and then self dot next. So self dot next will contain the initially it is none because there is no second element at the beginning. But once second element comes, this next part will contain the address of next node. Okay,
yeah,
is this clear?
yeah.
Okay, so now now what we'll do is we'll assign the array. For example, I am taking this as I am taking value as node one and node one is equal to I am taking um node of, so this is a class. I have created a class. This is node. Okay, let me make it capital so it will look professional. Node of, and I have taken, suppose first element is 32, then node 2 is equal to node of, then second element is 21. I have taken, then node 3 is node of let's say I'm taking 89, and then node 4. I'm just taking the four elements only. So this is node of suppose 15. So this is these are four elements are there which we have taken. Okay. Now in the data part, all these elements are now stored. Okay. Now the next part needs to be connected as well, right? So how we'll connect the next part? So we'll say um, node node one dot next is equal to n- node two. Like this will connect, right? Then node 2 of next is equal to node 3. Node 3 dot next is equal to node 4. Right now node 4 has nothing in it, so will not define anything for node 4 ending. Okay, so since there are only four nodes, so node 1 is as it is in end of node 1, node 2 will be connected, end of node 2, node 3 is connected, end of node 3, node 4 is connected, and end of node 4 there is nothing, so it will remain blank, so that will be null value. Okay,
Okay.
is this a small portion clear?
Yeah.
Okay, now what next we have to do is we have to print. Now how to print this? Okay, so in this what we'll do is first of all, um, since node 1 is the starting of this. Okay, so from starting we'll try to print. So suppose I'm taking head current head is equal to node 1. From here we'll start. Okay, and then while current node current node means while this current node exists. Okay, so here or you can use it like current node of next also, you can try while current node next not equal to none, like this also you can do when while current node of next not equal to node. So both things are possible. You can write just current node also, that will also work. So here I'll print this print um current node current head. Okay, and current head dot data part will print, and then end is equal to, and here like this I am just representing this as arrow or nothing, but nothing more than that, and then current node current head is equal to current head dot next. Okay,
Yeah.
is this clear? Now when you will execute this, so what is this? Okay, current, this is current. Okay, I'll execute. Oh, current head. Okay, so you can see 32, 21, 89. Now it has not printed this 15, right? Why it has not printed as 15? Because it is what I have done is current head of next not equal to null. So for when it will reach to node 4, what it will do is what it will identify is that next of this part is none. Okay. So
Yeah.
when this part becomes none, so automatically it will come out. So rather than doing this, what we have to do is current head, just like this we have to do, just current head, and here I'll put the colon. So what it will do is like this. Now it is printing till last. Okay,
Okay.
okay, and here with this means now if you don't want to print it like this, you can you can use a small logic over here, that rather than printing it like this, what you can do is if current head of n- of next is equal to not equal to and none, no any, then uh, print simply end is equal to like this. Okay. So when I'll execute this now, you can see, oh, this is coming two times. So we have to remove this. Yes, I'll remove this. Okay, and now you can see here it is printing like this. So now it is coming in next column. Every time it is coming in next column. Okay, let me take in this way. Let this move, let it be printed. We'll do some other arrangements so that it should not print the last one. Okay, so it will just next. So purpose of writing it over here is that it should not go on the next line. Okay, that's why I am printing it along with this. Okay, is this clear?
Yeah.
Okay, now, we have created our linked list, and this is what is traversing. This is what is um traversing the linked list. Okay, so this linked list is this first one is creating structure class for the linked list node. Okay, and then this part is assigning the value, assigning the values for the list. Okay.
Yeah.
So this way you can create your own linked list, and you can start working with this. Okay, if you want to insert more nodes, so you can do some more process like um, suppose you have to add suppose three more elements in this. Okay, so with three more elements, what you have to do, you can process it like suppose so let's take the value print sorry, more values is equal to integer input, and here I am asking enter the number of values you want to insert in linked list. Okay, and here we'll take the value, and based on that what we'll do is now in the same list I have to add some more values, right? So I'll just write it, adding more values to linked list. Okay, so now here what I am doing is simply, first of all, now since we don't have the address of this 18 at anywhere else other than this 21, only 21 knows where this 89 is, only 89 knows where this 15 is, and so we don't have the address of this 15 also. So what we have to do is first of all, from current node we have to, from first node we have to start. First of all, we have to traverse from this place to this place. First of all, we have to traverse that, and after that will start adding the element. Okay, so again this process will be applied again. Okay, so I am just taking current head is equal to node 1 while current head, while now we'll apply the condition while current head of next not equal to null. We'll apply it like this, not equal to none. Okay, we'll apply condition like this, and what we have to do is, sorry, this is ch only. This is ch not equal to null. Now ch is equal to ch dot next. Okay, so as soon we'll process this part, the ch will start from the first element from this element, and ch will this process will stop when ch will reach at this position, right? Now we have what we have to do is we have to insert new elements. So how many new elements? Suppose from this it has told that three new elements to be added. So suppose if I have to add the one new element, so what I'll do is ch dot next is equal to, and I'll just add this like node of, and suppose 11 sorry, 58 has to be added. I'll add it like this. So this is just adding a single element. Okay, this is
Yeah.
is this understood?
Yeah.
Okay, so again, I'll apply this traversing process. So what it will do is it will print. Now, suppose I am just taking just for this, and so you can see here this new element has been added over here. This is this now this new element is added. Okay, now what I want is I want to add multiple elements. Okay, so I'll automate this process in this. So next, so I'll just keep it at as is. Now what I'll do is well, um while count is less than and more values. Okay, while count is less than more values, or here I'll say count starting with 0. Okay,
Okay.
um, or I'll just start it as 1 and I'll do it as less than equal to 0. Okay, so now I'll ask from the user um n1, sorry, num is equal to integer input, enter the value. Okay, and once it enters the value, what we'll do is ch dot um ch is equal to um ch dot next is equal to node of num. Is this an inserted? Now ch is equal to ch dot next. Okay, this is what we have to do, and this will be done 3 times. Okay, are you able to understand this?
Yeah. One second. I'm just reading it.
Let me execute this first, and then I'll tell you.
Okay.
Okay, so let me see if this is working properly. So first of all, okay, now here it is asking how many values. So suppose I have to insert 3 values. Okay, now first value is 23, second value is 45, third value is 99. Okay, fourth. Okay, one more thing I have to do is count plus is equal to 1. This also I have to do, otherwise it will keep on asking. Okay, again I'll execute, enter the number of values. So I want to insert 3 values over here, and first value is 32, second value is 78, then this is 55. Okay, so now you can see here after 15 it has added 3 values over here. Is this clear?
Yeah.
So just take a look at the program and let me know if you want me to explain this again.
Yeah. Can you explain the more the
This
adding
part.
more values again. So we assign ch to node 1, then
Hmm.
use the while loop to traverse along the nodes until not
Until
equal.
until it reaches to last element.
Okay,
Okay. So when this will be completed, so initially means before this we have list like this. Okay. Up to here, this list is there. Ch from here, ch will start from here. Okay. And at the end of this, ch will be standing on this node. Okay.
yeah,
And then once this is completed, now ch is standing at here. Now what it is doing is it is asking how many numbers to be inserted, and then suppose three numbers are there, so this loop will work starting from 1 till 3. Now it is asking for a new number. This new number is ch dot next is equal to node. So once this is added first time, so now this is added over here. Okay, at the first iteration. Okay, now what this will do is ch is equal to ch dot next. So here at the first iteration, ch was here. Now, once this new node is inserted, ch will come from this position to this position. Okay.
okay,
Now it will again ask count of count value will be increases. This will be 2. This condition is true. Again, it will ask for new element, and again it will add a new element. So now after 78 is added, and with ch is equal to ch dot next, ch is from here it will be shifted to here. That is 78. Okay. And
okay,
then again count plus is equal to 1, count value is 3, this condition is still true. So this is num is equal to, it will ask again, and a new node will be inserted. So this is new node is inserted. Again ch is equal to ch dot next. From here ch will shift to this place. So once this is shifted, done, finish. Okay,
okay.
understood this.
Yeah,
So whenever you have to append any element, any new element, what you have to do is you have to add first of all you have to uh, go from first node till last node, and after last node you can add this. So you can use this part as append function.
which part?
Understood?
So, sir,
Hmm. Please ask.
yeah, so,
Append. Confused?
so ch through the first while loop, ch reaches the end of the nodes.
Hmm.
So that's ch's position. Then we use another to add the values to. So are
Hmm.
we,
So
where are
so
we
this
creating the new nodes?
I am creating new node on this. This is the statement for creating new node. Here we created no.
Okay, 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 okay.
In the same way, I am creating over here.
Okay, yeah, okay, makes sense. Got it, yeah.
Okay.
So
So
then why
this
do we
part,
write ch is equal to ch dot next?
so this ch dot next is why? Because now first of all we have created up to here. After
Yeah,
that, this new element is added. Now, whenever after this any new element will come, so that will be stored at this only. So ch
yeah,
was here, so ch needs to be transferred from this place to this place.
yeah.
That's why we are doing ch is equal to ch dot next every time.
Okay.
Okay.
Okay,
So
so that we can add value to the next node. Okay.
yes, yes. You can connect the next node with this node. Okay.
Okay. Yeah,
So,
makes sense. Yeah.
yeah, this is a little confusing, but if you will focus, you will understand. So this part is to traverse the um traverse from first node to last node. Okay, and this part is to this part is to add. the elements at the last. Every time the new element will be added to last. Okay.
Okay.
So you can make a function also for this. I have written it without using function. You can make your own function in this.
Okay.
Okay, so for traversing also you can make your own function so that we don't need to write. So you can write it like I'm just writing a function for traversing. So um, class I'm writing travel linked list. Okay, and here I am just passing the value nd. Okay, and here I am just writing this for the traversing. So Cn is equal to nd. This is the current node is there, and while Cn, and I am just writing the array for this. So this is print ch sorry cn dot data cn.data comma and is equal to like this I have added, and then cn cn is equal to cn dot next. Okay.
Okay.
Okay, so this is a function now I have made. Now wherever you want, you can use this function directly. Okay, so for example, if I am adding a new node again, so what I'll do is from current head dot next. So ch dot next is equal to node of suppose 49. Okay, now I'll just call this travel travel linked list, or here I'm giving um node 1. Okay, I'm giving this node 1. Okay, so now I'm just printing. Okay, first of all, this has to be executed, and then I'm using this nd, not class. This is def. Mm, okay, this list is added. Now I'll run this. So you can see here. Now it is printing all the value. At last, it is printing null. Okay.
Okay.
Understood. So you can make your own function also in this way so that you can see. So now here I was writing the entire function. Means here for traversing I was writing these two lines, and for here also I was traversing with two line. Okay. So here with this you can write it like this. So here I am making this travel. Mm, yeah, but just I'm taking writing it as print link list. Okay, and for traveling, I am making another. So def travel link list, and here I am taking nd as input, and here simply I am printing while cn dot next not equal to none, not equal to none, and here just cn is equal to cn dot next. Okay, so this is for printing the entire one, and this is for going from first element to last element inside the list. Now if anytime I have to go anytime I have to go in the list, we can move in this way. Okay,
Okay.
so you can make your function make functions to make your life easier in the list. Okay, so now onwards for printing I'll use this print function directly, and for traversing from one first position to last position I'll use travel linked list. Okay, so now for example if I, and now again I have to add a new element, and I have to print that. Okay, so what I'm doing is ch dot next is equal to, and I am adding node of 67, and okay, I'm deleting this. Okay, and so now whenever I have to add a new element, so I'm just printing where it is. Okay, yeah, this is okay. So now I have executed this. I'm inserting two new element into the list. So one is 33, one is 66, and you can see here. Now I have to add a new element. So what I'll do is, um, yeah, I'll do travel of link list, and I am giving node one over here. Okay, so this will travel from first to last here. Okay, Cn is equal to nd. I have to write. Okay, again to element 33, 44. Okay, node one, and then I'll add a new element. So the add new element is Cn. Where to go? Cn dot next is equal to node of this node of, and I am taking one to one, one to one. I am taking, and then print linked list, and node one I am passing. Okay, this C. Okay, this is Cn. I am taking return Cn. Here I'm taking last node is equal to this and this. Okay, understood now.
Yeah.
So now wherever I want to travel the linked list, I can use this travel linked list, and wherever I want to print the linked list, I can use directly this print linked list. That's it. No, again, every time I don't need to define an element and going from this first place to last place and writing that code. Okay, so now this will not be required anymore. This part. Okay, and this part will also not be required anymore. Just I have to call the print function with node 1, and with everything will be printed. Okay, is this clear?
Yeah.
Any doubt with this?
No.
Okay, now suppose I have to insert a new value in between. So this was appending. So this process was appending. You can make the function for this as well. Okay, so that at the need we can just call this function only. Okay, so you can make this function. So we'll see tomorrow. We'll make this function tomorrow, and then we'll make a interactive program. Okay, so now here this is a list. Now what I want to do is I want to insert a new element in somewhere between. So suppose I want to add a new element between 89 and 15, right? I want to add a new element at fourth position, let's say. So fourth position is this. So here now 15 should move forward. A new element will come here, and that new element will have the address of this 15. Understood?
Yeah.
So what in this case, what you have to do in this case, now 89 has the address of 15. This will be stored at third variable. Okay, and the new the new address will come at 89. So let's see how we can do it. So let me make a function directly for it. I'll make a function. So def and insert. Okay, and the new element I'll just take as okay. New element will take at runtime itself. Suppose we have to insert a new element, so I am taking up value as position. So position I am taking. Okay. Now what we have to do is we have to traverse um, not the position based on position. Let's take. So we have to what to say at position we have to go, so we have to take a count. Okay, so here we'll take count starting at 1. Okay, and while what we'll do is while now what we'll do here, I'll pass the node 1 as well. Node 1 as nd I am taking. So here I'm taking current node is equal to nd. I'm taking this full name. Current node is equal to nd, and um, while is count is less than position. Okay, while count is less than position. So what it will do is it then uh, current node is equal to current current oh what I'm doing current node dot next. It will move to next position, and count plus is equal to 1. Okay. Now it has reached to the suppose fourth position, and now what we have to do is so it will reach at third position by this. So what I'll do is now um, we'll make a temporary node over here. So temp node is equal to node. This is a temporary node created, and now temp underscore node dot next is temp dot node next is uh, current node dot next. Okay, just see, I'll explain the logic again. Don't worry about that. And now I'll ask the element to be insert. So suppose insert val insert val is equal to integer input. Enter the number to be inserted. Okay, and here now what I'll do is temp underscore node dot um temp underscore node dot yeah, okay, temp underscore node is equal to node of or whatever the insert value is, insert underscore val. Okay, and now current node dot next is equal to temp underscore node. Okay, आई
Okay.
गेस ये आपको समझ में अभी नहीं आया होगा, बट लेट मी, समझ में आया कुछ थोड़ा थोड़ा?
हाँ, थोड़ा आ गया था वाइल उसके
हाँ,
बाद। हाँ।
so now I'll just test it and then I'll explain the logic. Insert, and suppose फोर्थ पोजीशन पे हमें इंसर्ट करना है और यहाँ पे हम नोड वन को हम यहाँ पे पास कर देते हैं, ठीक है, और हम इसको एग्जीक्यूट कराते हैं। हम्म, और इसकी जरूरत नहीं है हमें। How to create the temporary node over here? Node one. Okay, so the value to be inserted, suppose I am taking 22, and now I am printing. Let me just take print linked list. Okay, so this is inserted at this fifth place. We were expecting this to be at this place. So what we have to do? Position minus one. Okay, yes, up to position minus one only we have to go. Then only, since we need it at fourth place, so we have to go till third position only. Correct?
Yeah.
Okay, so let me execute this again. So I am taking this three value over here. So 33, 44, 55 I have inserted. Now, now I'll execute this. So here, now I am asking 2, 2, 2 is to be inserted at fourth place. Okay, and I'll execute this now. So you can see this 222 has come at this place. Okay,
Yeah.
so now let me explain. What we are doing is we are making the insert function using here I am passing the position of first element. So in linked list, or whenever we are going to do any process, first of all, every time we have to give the position of first element. This will be there. Then along with this here we are going to insert. So we have to give the position where this value needs to be inserted. Okay. Now, what I'm doing is count. We have initialized as one for the counter of the position, and this current node is initialized with the first value so that we can move this ahead. Okay. Now, since we have to insert at fourth position, so wherever we have to insert, first of all, we have to stop at its previous position. So I am taking position minus one till position minus one only. It has to go, and then it has to stop. Okay, so by this, it will start from this place 32, then 21 and 89. So as soon 89 will trigger, it will stop because three positions are over already. Now, insert value, whatever the value to be inserted, that will be checked over here. For that, node will be created, and for that, next the current. So this 15 is connected with this at current node. So address of this 15 will be placed at this temp node. Okay, and then the address of this temp node will be allocated to this third place current node. Okay.
Okay.
Just revise this once, so you will be able to understand this.
Yeah.
Okay. And these programs are little lengthy programs and a little confusing programs. So once you will practice it by yourself, you will be able to understand this easily. Okay.
Okay.
Is this clear for you?
Yeah.
Let me save this. So if now linked list will take 2 3 days. Linked list. I'll just rename this. So this process is done. Tomorrow we'll make this adding element part also into the function, so that further we can introduce all the functions together and we can make an interactive program. Okay.
Okay.
So we'll keep it at this spot today. Thank you.
Thank you, sir.